Hi everyone, this is Group B, and we are going to present our project on Garbage and Recycle Automated Disposal Bot, or for short, GRAD. Let's meet the team first. We have Hiba, who is studying computer engineering, working on the microcontroller, IR sensory, and the communication system. Joined by Sadia, who is also studying computer engineering, working on software and sensor system. Sean, who is studying electrical engineering, working on solar, power, and PCB design. And myself, Abdul Salam, I'm also studying computer engineering, working on drive system, physical design and housing, and software.
The motivation behind our project is for those that have any physical demands of taking out the trash, as well as anyone that ends up forgetting to take out the trash or ends up going on vacation and forgetting to take out the trash as well. Our GRAD system will be the solution to those problems by eliminating all the physical needs, incorporating ease into taking out the garbage, and facilitating efficiency.
Now I'm going to go over a few of our requirements and specifications. As you can see here, we have 3 deliverables that are highlighted that we'll be demoing today. We still have not really completed the first deliverable that you can see here, because that will be more for when the project is finally completed. However, we'd like to go over solar charging voltage. We're going to display that the solar panel charger that charges the battery will be between 13.8 and 14.1 volts. This will be for optimal battery charging. We'll also display our latency in terms of our action. So essentially when the robot is acted to do something, whenever a notification is sent, it should act within, at least within 2 minutes. We expect to have a faster latency and have a better optimization once we test more. But for now, we'll just show that, and then we'll move on to object detection and safety measures, which we want our object to stop within about 1 to 2 feet of seeing an object. We'd also like to get at least 20 pounds of waste in the garbage can. This won't be specifically displayed today, but in future, after testing and getting the final project assembled, this is our goals. With object detection avoidance, we essentially want it to avoid obstacles at an 85% success rate. And protection systems, we want it to at least wait 10 seconds before continuing when it detects an object.
Hold on. Now, values are 0, 0 for drive to curb and go home. We will now press the button on the Android emulator, and the values are going to update in the serial monitor. And if you minimize that, you can see that's also updated in the database right here. All right, let's turn on return flag or return home. You press it. And it's working. And here it is in the database as well. Record that we had something working. So currently we are sending information from our cute little ESP here. It's reading information from the database, and we have it plugged into our Arduino into the serial communication pins TX1 and RX1. And now we are going to pull up our emulator, which contains our app. If I hit drive to curb, it should be detected by the ESP and transmitted to the Arduino, and as you can see, it prints detected drive on the screen. If I press return home, it's going to also print detected return. And that's just some garbage values that we are going to ignore.
Log out and log in again.
If I log out, all the values are going to go back to 0. And
you need to log in again.
Oh, right, okay. heba123@gmail.com. I'm gonna log in, and as soon as I log in, the values go back to 0 and the detections don't print out.
I was like, What is he doing?
Give me right. Okay. Forward. I'm gonna do right. Now we do left. Forward. Stop. Left. Right. Okay. Forward and obstacle. Obstacle. There we go. Test. Stop test. Stop test.
Now that we've reviewed some of the videos of our achieved successes, we'll go over our milestones that we have completed. So far, we have our battery charger implementation. As you can see from the first video, our charger was charging at the proper voltage. We've implemented our Firebase database, which allows us to communicate with our GRAD system. We've implemented our motor control, so our motors are working properly as desired, and we have implemented it with our IR sensors. This allows us detection of any line that is on the ground and will allow us to get to the proper destination from our start place. We've also implemented object detection testing. As you can see, we use our ultrasonic sensor to detect objects that are about 2 feet away. While this isn't the best results, we plan to implement more testing to get better results. We've implemented this all together as well in one of the last videos with the object detection of the ultrasonic sensors, as well as the line detection with the IR sensors to get a better result. And then we also implemented Wi-Fi for communication systems, so we can tell our robot to move when desired and return home when desired. We've also compiled all of the PCB parts as well as the board, and we plan to integrate all this together once final code has been ran.
Regarding next steps, the first thing that we have to do is integrate the code for the path planning and the Wi-Fi so that we can make our trash bot Wi-Fi enabled. The second thing we have to do is move the microprocessor from the Arduino and solder paste it onto our PCB. Next, we're going to have to attach the solar panel on top of our trash bin, and after that, we're going to have to stabilize all of the wire placement and add our obstacle avoidance sensors to the garbage bin. In addition, we're going to have to do some extra testing in order to make sure that our project is safe and add measures against electrical shock. And lastly, our stretch goals are to implement a trash level detection using IR sensors, which would report the percentage that the garbage bin is full, and implement notifications with obstacle detection and regarding if the trash has been delivered to the curb and if it has returned home.